Okay, we're going to continue analyzing acids and bases using this qualitative tool, ARIO. And now let's go and study atoms. So we're going to be studying the type of atom where the negative charge resides in the conjugate base when we're looking at these reactions. So we're looking at where is the negative charge in that conjugate base. So let's see a couple of examples on that. Say that I have in this with a negative charge and now that. Now here, what we're saying is that the negative charge is on a carbon. Here the negative charge is on an oxygen. Oxygen means more electronegative. If you guys remember the periodic table, second row is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and electronegativity increases this way. Being fluorine, the most electronegative in all the series. That means negative charge is better, is more stable on the more electronegative atoms. So we're predicting here that this anion is more stable than this one. And if it is, then that makes the acid stronger because now this will dissociate better. So the more stable this is, the more stable the anion is the stronger the acid. And so here we're predicting stronger acid, the more stable the conjugate base. Stronger acid. And if we look at the pKa chart, actually the pKa for ethanol is 16, and the pKa of the conjugate acid here, which will be propane, that's an alkane, so it's close to 50. So this one is much smaller, so much stronger acid. And we had predicted that using the fact that at the conjugate base, the charge is on an oxygen. Now, if we analyze, this is analyzing elements that are in the same period of the periodic table. So we were comparing charge on carbon versus charge on oxygen. Now, let's compare something else. Let's see if I have now a couple of structures, if we can make a prediction here. Now, if we do this, now this time we are comparing atoms, so oxygen and sulfur, but they do not belong to the same period. Actually, sulfur is right below oxygen. That is, the atom is much larger. So being larger atom, that negative charge is actually spread on a larger volume. So this anion, we're predicting that this will be more stable. And is, again, notice that I am analyzing two atoms which within the same group or family in the periodic table. Different to that, these atoms were in the same period. Here it is in the same group. So I am highlighting then this same group as the periodic table. This being larger, now the most important effect on the group then would be size. Sulfur being larger than oxygen, this anion is more stable, and therefore I am predicting that the conjugate acid of the, say, this will be stronger than the conjugate acid here. Again, based on the stability of the anion, my prediction is that this anion, because the charge is on a larger atom, this will be more stable. Therefore, its conjugate acid right here will be stronger.